Okay, let's try one more practice problem. This one is actually from a lab that we did just right before spring break, and it's with the decomposition of baking soda, sodium bicarbonate. So the question here is sodium bicarbonate decomposes when heat energy is absorbed. So here's the equation for the decomposition of sodium bicarbonate. It decomposes into these three subunits. And this is how much energy is required for this reaction. So in order to figure out how much energy this is in terms of moles used here, we actually have to balance this out. So when we're looking at the sodium bicarbonate, it's decomposing into these three things. And this first subunit has two sodiums. So that means we would have to start with 2 moles of sodium bicarbonate in order to produce this subunit. So that gives us 2 sodiums and 2 sodiums. We would also have 2 hydrogens, and we have 2 hydrogens in the water. We would have to have 2 carbons, and we do have 1 carbon here and 1 carbon here. And then total, we would need 6 oxygens because we have 2 of these molecules. So that would be 6 oxygens total. So here's 3 here, 2 here, and 1 here. So this whole thing is now balanced. Now, we don't typically put anything here when there's 1 of those. I'm going to go ahead and do that right now to fill that in, just so you can see that 2 moles of this would produce 1 mole of this, 1 mole of this, and 1 mole of this. Now, if we have 2 moles of sodium bicarbonate decomposing, then this is the energy needed. Now, in the most circumstances, we're not going to have 2 moles every single time. So in the question, it says how much heat energy is needed to decompose 8.5 grams of sodium bicarbonate. Now I just randomly came up with 8.5 grams because we normally don't have exactly 2 moles of sodium bicarbonate. So in this circumstance, we're just pretending that we're starting with 8.5 grams of the sodium bicarbonate. All right, so how do we figure out how much energy is needed to break that down? Well, if we go back to semester 1, the only thing we can really convert grams to directly is to moles. All right, now we can use our coefficients here to convert from grams to moles. These are 2 moles of this, 1 mole, 1 mole, and 1 mole. But we have to have some conversion factor in order to actually get from grams to moles. And that conversion factor is the molar mass. The masses on the periodic table. The units on these masses is grams per mole. So for example, I've got 22.990 grams per mole of sodium. Also in sodium bicarbonate is hydrogen. 1.008 grams per mole is hydrogen. If we look over at carbon, 12.011 grams per mole. But the important thing is grams per mole. So down here, I'm going to write NaHCO3. And on the periodic table, 22.99 grams per mole is sodium. If we look at hydrogen, 1.01 grams per mole is hydrogen. If we look at carbon, 12.01 grams per mole. And then if we look at oxygen, 16 grams per mole. Now with oxygen, it's a little unique because there's the 3 subscript. So that actually means we have 3 of those. So in total, the oxygen is going to be 16 times 3, so 48 grams per mole. All right, so if I want to convert this 8.5 grams of sodium bicarbonate into moles to eventually get to energy, I'm going to have to use the molar mass to figure out what 1 mole of sodium bicarbonate is. All right, so to figure that out, 1 mole of sodium bicarbonate has 22.99 grams of sodium. It has 1.01 grams of hydrogen. It has 12.01 grams of carbon, and then 48 grams of oxygen. So what I have to do is I have to calculate the total of all of that. So 22.99 plus 1.01 plus 12.01 plus 48. So 84.01 grams per 1 mole of sodium bicarbonate. So that's how we convert from grams to moles, is that molar mass. So all of those added together, 84.1 grams, that is the mass or grams per 1 mole of sodium bicarbonate. Now, we want to figure out how much heat energy is needed. So now I'm in moles. My grams of NaHCO3 are canceled out, and now I'm in moles, but I need to get out of moles and into energy, all right, kilojoules. So in my equation, all of these coefficients represent moles, and I wanted to know about sodium bicarbonate. So I'm going to look at the sodium bicarbonate. That coefficient is moles, so 2 moles of this will produce, or sorry, not will produce, will absorb that much energy, 91.5 kilojoules. Now my moles of sodium bicarbonate is canceled out and I'm left with kilojoules. So if I solve this, it will answer this question. So let's do that. 8.5 times 91.5 divided by, and then I'm going to put these in parentheses because I want to abide by the order of operations. 84.01 times 2. My answer is 4.63 kilojoules. All right, so it would take 4.63 kilojoules of energy, heat energy, to decompose 8.5 grams of sodium bicarbonate.